Alright, welcome to your quick math tutorial on our third index law. So let's get straight into this with an example. Alright, so let's say we had 2 to the power of 3 and we raised that all to the power of 2. So let's say we wanted to simplify this expression and we wanted to put it in its simplest index form. So how would we go about doing that? Well, first of all, let's remember that a to the power of m equals a times a times a m times. So if a equals 2 to the power of 3, then a squared equals 2 to the power of 3 times 2 to the power of 3. We have our 2 times. And so if we have 2 to the power of 3 all raised to the power of 2, that's equivalent to saying 2 to the power of 3 times 2 to the power of 3. And if we were to write that in another form, we have 2 times 2 times 2 times 2 times 2 times 2. And if we count how many 2's we got, we have 1, 2, 3, 4, 5, 6. We have 6 2's. And so 2 to the power of 3 all raised to the power of 2 equals 2 to the power of 6. And notice that 6 is the product of both of our powers here, which leads us to the following result, that a to the power of m all to the power of n equals a to the power of mn. Alright, so we have two problems here, and you can go ahead and you can pause the video and give these a go yourself if you like. Alright, so let's start with question A. What do we have here? We have 7 to the power of 3, and then all of that to the power of 2, divided by 7 to the power of 2. And so we're going to work according to BIDMAS, and we're going to use our BIDMAS rule. And we know that the first B stands for brackets, and that we're going to deal with our brackets first. So we'll evaluate 7 to the power of 3 all to the power of 2 first, and for that we're going to use our third index law. And so what we have is 7 to the power of 3 times 2, which is 7 to the power of 6. So that's the first part of our solution done, complete. And so now what we'll do is we'll just substitute that in as the numerator, 7 to the power of 6 over 7 to the power of 2. And then we'll use our second index law. So we have 7 to the power of 6 minus 2 equals 7 to the power of 4. Alright, so moving on to our next question, we have 2 to the power of 3, and then all of that to the power of 2 multiplied by 2 to the power of 3. And so we're going to use our brackets. We'll start with our brackets first. We'll evaluate what's in the brackets. So we'll have 2 to the power of 3 all to the power of 2, and we'll use our third index law. And so what we have is 2 to the power of 3 times 2, which gives us 2 to the power of 6. And then we'll have 2 to the power of 6 multiplied by 2 to the power of 3, right, because we substitute that in. And then we'll use our first index law. So we have 2 to the power of 6 plus 3 equals 2 to the power of 9. Moving on to our next set of questions, we have question C and D, and you can go ahead again and pause the video and try to do the working out for yourself. Alright, so we have question C. Let's start with question C. Alright, so we're going to start with what's in our brackets first because we're using BIDMAS, and so we'll evaluate the 5 to the 0 to the power of 3, and for that we'll use our third index law. So we have 5 to the power of 0 all to the power of 3. In fact, we don't even have to use our third we can even say, you know what we could do? We can just say, we know that 5 to the power of 0 is 1, right? So we just have 1 to the power of 3 multiplied, and we know that 5 to the power of 0 is also 1, so we just have 1. And we can say 1 to the 1 just to be clear. In fact, we can even go the extra mile and say that the answer is 1 to the 4. We know it's it's just 1, right? All right, so let's move on to our next one. We have what we have here actually is that we have a rational expression here, and and then this is all in brackets to the power of 3. And so we're going to handle what's inside the brackets first. So what we have is that we have 3 to the 3 all over 3 to the 2. And so we'll use our second index law, which tells us that 3 to the power of 3 minus 2 equals 3 to the power of 1, or just 3. And then of course don't forget to cube it after. So what we have is we have 3 cubed. There's our answer. Okay, so we have some further problems here, a little bit more tricky, but definitely worth the squeeze if we do them. Don't be concerned with our y and our x terms. The index laws still hold in this case, as long as our bases are the same. These terms here are our variable terms, whereas a term like 2, for example, would be called our constant terms. The reason why y and terms like y and x are called our variable terms is because they can vary in the values that we assign to them. So y could be 2, it could be 3, it could be anything. But our index laws, they still hold. For example, if we're dealing with y to the cubed and y squared, we could work with these numbers, right? Because both of the bases are base y. Whereas if we have y and x, then we can't work with y and x. All right, so you can go ahead and pause the video like in our last question and try to give it a shot yourself, and let's begin. So what do we have here? We have y cubed multiplied by y squared and then times that by 2x squared in brackets to the power of 3. So naturally I would want to start off with this part of the expression first, the brackets, but I don't think it's going to do much if we just begin with the y expression. So let's just begin with this. So we have y cubed times y squared, and then we'll use our first index law, which will give us y3 plus 2, which is y5. And then dealing with our next term here, we have 2x squared, and then we're raising that to the power of 3, which gives us really 2x squared times 2x squared times 2x squared. And we can further simplify that. We have 2 times 2 times 2, which is 2 cubed. And we can multiply that by x squared times x squared by x squared, which is x squared raised to the power of 3. And then we can simplify this further. This will be 8, and this will give us x to the 2 times 3, which gives us 8x to the 6. And so we worked out our second part of the solution, and so our final answer, we could write it like this: 8 y to the 5 x to the 6. Alright, so moving on with our next question, we have x cubed raised to the power of 2 over xy, and we can break this expression up as x cubed over 2 over x times 1 over y. And we can then evaluate our expression in the brackets, and so we'll use our third index law, which would give us x to the 6 over 5, over x times 1 over y. And then we'll use our second index law for this one, which gives us x to the 5 over y. And that brings us to the end of our quick math tutorial on third index laws. Join me again next time and we'll be looking at some of the implications of our index laws. So if you found this content useful, don't forget to like and subscribe, and I will see you again soon. Bye bye.